In this video tutorial here, I'm here to show you how to use the tracker software to look at the video of your rocket launch and to analyze it for velocity, distance, and acceleration. So the first thing we need to do is we need to go over here and we need to open up our video. So we are going to look for the trial video. So from here, what we're going to do, our first option is we need to select this right here, where it says show or hide the coordinates axis. Now you'll see here it's a purple ruler. What you need to do is you need to align the vertical one with the beginning of your rocket and the purple one where you expect it to land. Now I'm planning on making all my tracking from the top of my rocket, so I'm lining the purple line up with what I would consider to be the top of the rocket. Our second thing is we need to give the video a scale. So we need to go to this button right here where it says the calibration tools. And I'm going to click on it and I'm going to pick the calibration stick. Now you'll see it's right here. What I need to do is I need to move the plus signs. Now I'm going to move one side of the plus sign to one side of my meter stick here. And then the plus sign to the other side of the meter stick. It's important to have a reference in the video so you can see what you're looking at. Now this meter stick is 1 meter long. So let's adjust that and make that 1.0. Now it's a meter long. Now if you follow my mouse, you're going to see I'm hovering over top of the play button. Now the play button will show me the video of the rocket moving. And we can see it launches and then it lands. We want to do an analysis on it. What we need to do is we need to take our slider back here and we need to move it towards when the rocket takes off. Now I've approximately got the right section where the rocket takes off, about frame 17. But if I think I've got it wrong, what I can do is I can move over here. This is the forward tool. And you can see I'm pressing it, the rocket's moving. As you'll see, I've went too far. So I'm going to move over and I'm going to use the step back key to what I think is where the rocket starts. Done. Now that I think I'm at frame 24, I feel I've got this perfect, so I'm ready to start tracking. So what I need to do is I need to go up to the top here where it says the create button. I'm going to create a new track. So I click on it and I'm going to click on point of mass. Now it doesn't matter whether you pick the front of the rocket or the back of the rocket. What's important is whatever you pick that you stick with it. I personally think it's easiest to do the front, so that's what I'm going to do. So what I'm going to do is on my keyboard, I'm going to press the control button. And if you look at where my mouse pointer is, when I press the control button, it goes from being a pointer to a square. I let go of the control button, back to the pointer. Press the control button again, it's now a square. Now if you look, there's a plus sign in the center of the square. That's important. What I need to do is I need to aim what my reference point is going to be, which is the top of my rocket. And I'm going to click here. And when I let go, it moves it to the next frame for me. So I press the button again. I press it again. Press it again. And you can see right now my rocket's not moving. That's okay. And that's because the program reset itself. If you happen to have that happen, it's important that once you put down your first point, that you don't make a break. You need a dot for every single frame of video you're going to be analyzing. So I will continue to click these. Now we can see there start to be rocket movement. And I will continue to do this. I know it's a little hard to see sometimes, that it gets blurry, This will be one of those times where you just have to use your best judgment. And the data won't be perfect, but that's okay. Okay. So I'm done. I've tracked my videos, and as you can see, the red line. Now you can see there's a big gap in here. I didn't do a particularly good job of analyzing it. So I'm going to hit pause now and do a better set. So now I've redone the data, and you can see it's a little bit smoother this time. From here, what I want to show is what's of interest to us is our graphs right here. And what you'll see is you can change the axes on here fairly quickly. Now you'll see right here, I'm comparing the distance in the x component to versus time. And it shows that the rocket traveled from left to right. That makes sense. Actually, I gotta change the scale. We can also adjust right here for the y component. And it says pretty much what we would expect. The rocket went up about 1.3 meters and then hit the ground. Now we can take a look here. We can look at the velocity. Now these are fairly ugly numbers, but what I want you to do is try to figure out what you would view as being the line of best fit. Somewhere between 1.8 and 2 meters a second it was traveling. Had no real acceleration. That's to be expected. Now if you think rocket in the y, you would expect to see an acceleration. You would expect to see a slope coming straight down here. And that's what we see. Now we've also got the ability to look at acceleration. Yet again, we can look at the line, we can see our acceleration in the horizontal, the x-axis, is somewhere around the 0 line. That makes sense. If we're talking the y-axis, we would expect the acceleration to be about negative 9.8. And we can see that's true. We can see that what's accelerating it is due to gravity. So let's look at this in a little bit more detail. I'm telling you the slope of this should be around negative 9.8 because it's velocity in the y-axis, so up and down. So we would expect the acceleration to be 9.8. Can we prove it? We can. We want to right-click on this graph here, and we want to pick the Analyze button. We pick the Analyze button, we get a little bit more detail about the graphs. From here, we can yet again switch it up if we want. Now, I'm interested in the slope, so let's put a line of best fit. Now, if we take a look here, we've got our pink line here, and the pink is going to correspond to about negative 8.08 meters per second, or the B, which is about 9.8. Now, if we look at the fit equation, this is basically y equals mx plus b, with the a here representing our slope. When we look over, our slope is about negative 8. So not quite what we would expect. We'd expect it to be perfect 9.8, but given this is a quick demonstration, it gives us a rough idea to compare against.